Mars, the mysterious red planet, has always been a source of wonder and intrigue. For years, it seemed like a barren wasteland, but recent findings have shaken this perception. Scientists have uncovered something unexpected, something that could change everything we know about our neighboring planet. What lies beneath the surface might just be the key to answering one of humanity's biggest questions. Hidden in the harsh, cold terrain of Mars is something that could rewrite history. What has been found, and why does it matter so much? Keep watching as we uncover the startling truth about Mars. The discovery of liquid water on Mars is one of the most groundbreaking revelations in the history of space exploration. For decades, scientists have speculated about the possibility of water on the red planet, given its geological features that resemble ancient riverbeds and lake basins. These speculations fueled numerous missions aimed at understanding Mars' past and present environment. The confirmation of liquid water beneath the Martian surface, however, has transformed these speculations into a concrete reality, igniting new hopes and questions about the planet's potential to harbor life. This discovery isn't just about water, it's about rewriting our understanding of Mars. The presence of liquid water suggests that Mars may be more dynamic than previously thought, with the potential for active geological processes and a more complex climate system. The implications extend beyond Mars itself, offering insights into planetary formation and the potential for life on other celestial bodies. Moreover, finding liquid water on Mars directly influences future exploration missions. It adds a layer of urgency and excitement as the possibility of life-supporting environments becomes a key focus. The discovery also underscores the importance of advanced technology in space exploration. From the Mars Reconnaissance Orbiter's instruments to the Mars rovers drilling into the planet's surface, each technological leap has brought us closer to this monumental find. In essence, the discovery of liquid water on Mars marks a new chapter in our exploration of the cosmos. It is a milestone that redefines Mars from a barren, desolate world to one that may hold the keys to answering one of humanity's oldest questions. Are we alone in the universe? Mars has long been depicted as a barren, dusty desert, with its iconic red hue symbolizing a planet devoid of the lush landscapes and flowing rivers we associate with Earth. However, this image has been challenged by increasing evidence suggesting that Mars was once a much wetter world. The planet's surface is marked by features that strongly resemble ancient river valleys, deltas, and lake beds, indicating that liquid water may have once flowed freely across its surface. These geological features point to a time billions of years ago when Mars had a much thicker atmosphere, capable of supporting stable bodies of water. Scientists believe that during this period, known as the Noachian era, Mars may have had a climate warm enough to sustain vast oceans, lakes, and rivers. The discovery of these features has led to the hypothesis that Mars was once a habitable environment, potentially capable of supporting microbial life. Despite the current cold and arid conditions, the idea of Mars as a watery world has gained traction with recent discoveries of water ice beneath the surface and signs of seasonal flows of liquid brine in some regions. These findings suggest that while Mars may not have vast oceans today, it still retains significant amounts of water, albeit in less accessible forms. The shift from viewing Mars as a dry desert to considering its past and present water reserves is crucial in our understanding of the planet's history. It opens up new avenues for exploration, particularly in the search for ancient life and the possibility of future human colonization. If Mars was once a watery world, the question now is whether remnants of that water still persist in forms that could sustain life, making the red planet a focal point in the search for extraterrestrial life. However, it wasn't until the development of advanced space exploration technology that definitive evidence of liquid water was found. The turning point came in 2015 when NASA announced the discovery of hydrated salts in recurring slope lineae on Mars. These dark streaks appear on the slopes of craters and other steep terrains during warmer months and fade in colder seasons, suggesting the presence of liquid brine that flows and then evaporates. The detection of hydrated salts, specifically perchlorates, indicated that these streaks were likely formed by water with a high salt content, which lowers the freezing point and allows it to remain liquid even in the harsh Martian environment. This discovery was made possible by the Mars Reconnaissance Orbiter, equipped with the high-resolution imaging science experiment camera and the compact reconnaissance imaging spectrometer for Mars. These instruments provided the detailed imagery and spectral data needed to analyze the chemical composition of the surface and confirm the presence of liquid water. The implications of this discovery are profound. Liquid water is a key ingredient for life as we know it, and its presence on Mars raises the possibility that microbial life could exist, or may have existed, on the planet. Moreover, the presence of liquid water has significant implications for future human exploration, as it could provide a crucial resource for sustaining life and producing fuel. The evidence for water on Mars has evolved significantly over the years, transitioning from the observation of surface features that suggested ancient rivers and lakes to the direct detection of water ice and potential underground reservoirs. This journey of discovery has been marked by a series of findings that collectively build the case for the presence of water in various forms on the red planet. One of the earliest and most compelling pieces of evidence comes from the polar ice caps on Mars. These ice caps, composed mainly of water ice with a layer of dry ice that sublimates with the changing seasons, have long been visible through telescopes. The existence of these ice caps indicated that Mars had retained some water, though it was mostly locked in frozen form. Seasonal changes in the ice caps, observed over decades, suggested that Mars had a dynamic climate capable of influencing its water reserves. Beyond the polar regions, the detection of subsurface water ice became possible with the advent of more sophisticated instruments. The Mars Odyssey spacecraft, using its gamma-ray spectrometer, identified vast amounts of hydrogen just below the surface, strongly indicating the presence of water ice. These ice deposits were found in significant quantities at higher latitudes, further supporting the idea that Mars harbors substantial water reserves beneath its surface. The most exciting development, however, has been the potential discovery of hidden liquid water reservoirs beneath the Martian surface. In 2018, data from the Mars Express spacecraft, equipped with the Mars Advanced Radar for subsurface and ionosphere sounding, revealed signals that scientists interpreted as a subsurface lake of liquid water beneath the southern polar ice cap. This finding suggested that, despite the cold temperatures, the pressure and presence of salts might allow water to remain in a liquid state underground. The discovery of liquid water on Mars has profound implications for the possibility of life on the red planet. Water is a fundamental ingredient for life as we know it, and its presence significantly increases the chances that Mars could harbor some form of life, either in the past or present. This revelation transforms Mars from a cold, barren world into a more dynamic environment where the building blocks of life might exist. The presence of liquid water, particularly in the form of briny flows detected in recurring slope lineae, suggests that there may be microenvironments on Mars where conditions are favorable for life. These briny flows, which appear seasonally, could provide the necessary conditions for extremophiles, microorganisms that thrive in extreme environments, to survive. On Earth, extremophiles have been found in some of the most inhospitable environments, such as deep-sea hydrothermal vents and highly saline lakes, providing a precedent for potential life on Mars. Moreover, the detection of water ice beneath the Martian surface and the possible existence of subsurface lakes, like the one detected beneath the South Polar ice cap, offer even more promising habitats. Subsurface environments could be shielded from the harsh radiation and extreme temperatures on the Martian surface, creating stable conditions where microbial life could persist. These potential habitats raise the question of whether life could have originated on Mars when the planet was warmer and wetter billions of years ago, and whether it could still exist in these protected environments. The implications extend beyond the search for life itself. If life is found on Mars, it would have profound consequences for our understanding of biology, evolution, and the potential for life elsewhere in the universe. It would suggest that life is not unique to Earth and that the conditions necessary for life might be more common than previously thought. This would fundamentally change our perspective on the cosmos and our place within it. In addition to the scientific implications, the discovery of liquid water on Mars has practical implications for future human exploration. Water is essential for sustaining human life, and if accessible sources of water can be found, it would greatly enhance the feasibility of long-term human missions to Mars. Water can be used not only for drinking, but also for producing oxygen and hydrogen, which could be used as rocket fuel, making Mars exploration more sustainable.